Hello, this is about the structure of the atom. Okay, atom contains three fundamental particles. They are electron, protons, and neutron. So, electron was discovered by J.J. Thomson in the year 1900. J.J. Thomson in the year 1900, and proton was discovered by Ernest Goldstein in 1886. And Newton was discovered by J. Chadwick in the year 1932. These three particles are present in all the atoms, in all kind of atoms. And uh, the symbol of electron is small e. We denote electron by small e, and proton with small p and neutron with small n. Now the question is how these particles are arranged in an atom. The arrangement of these particles in an atom is really a big question. So first came Thomson model. Thomson, he wanted to explain the arrangement of particles in an atom. He said that atom is like a Christmas pudding. Okay, the electrons in a sphere of positive charge were like currents. Currents means dry fruits. Okay, he also said that like a watermelon. Okay, he wanted to explain in this way. He said that the positive charge in an atom is like a watermelon, and the electrons are the seeds of the watermelon. Just like the seeds are scattered in the watermelon, so the electrons are just like seeds, and the watermelon as a whole that we eat is a positive proton it is. So Thomson proposed that now the atom consists of positively charged sphere and the electrons are embedded in it. This was his model, and the negative and the positive charges that are equal in magnitude. Magnitude means in number. So the atom as a whole is electrically neutral. But this Thomson model of atom was not accepted by scientists. The one thing that was accepted by scientists is that atom as a whole electrically neutral. This was accepted in America, but the model that he gave was not accepted by scientists. Okay, the next came Rutherford. Now, just to explain this arrangement of electrons, protons, and neutrons in an atom, he carried out an experiment, and that is known as gold foil experiment. Okay, gold foil experiment. This was a very important experiment, and this gold foil experiment so brought out many knowledge about the arrangement of electrons, protons, and neutrons in an atom. So what he did, that he took gold foil that was about 1000 atom thick. The thickness was about 1000 thickness of the gold, because why he took gold here, because gold is the most malleable metal. It can be hammered into very thin sheets, right? That is why he took gold. And he bombarded this gold foil with alpha particle. What is alpha particle? This is the nucleus of helium atom whose mass is 4U, or unified mass. U is for unified mass. And so, what was his observation? He observed that most of the fast moving alpha particles passed straight through the gold foil. Passed straight through the gold foil. Okay. Some of the alpha particles were deflected by the foil by small angles. And third, he observed that surprisingly, 1 out of every 12,000 particles appeared to rebound, means they reflected back on the same path. So this was his observation. Okay. Okay, at this experiment, Rutherford was surprised terribly. He did not expect such observations. So, what was his conclusion about this? So, most of the space inside the atom is empty because most of the alpha particles pass through the gold foil without getting deflected. This was his okay first conclusion, because most of the gold alpha particles passed straight. Second, very few particles were deflected from their path, indicating that positive charge of the atom occupies very little space. Positive charge, because alpha particles itself are positively charged particles. Third, a very small fraction of alpha particles were deflected by 180 angle, including indicating that all the positive charge and the mass of the gold atom were concentrated in a very small volume within the atom. Okay. So this was his conclusion. Now, what was his model? His model is that there is a positively charged center in an atom called the nucleus. Nearly all the mass of the atom resides in the nucleus. Okay, he said that on the basis of his observation, he has put forward the model of atom that there is a positively charged center in the atom called the nucleus. Nearly all the mass of an atom resides in the nucleus. And second, the electrons revolve around the nucleus in a well-defined orbit. Well-defined orbit. Okay, not in any orbit, but a well-defined orbit. And third, the size of the nucleus is very small as compared to the size of the atom. This was now there was a drawback of Rutherford models of atom. Scientists say that when the electrons are moving around the nucleus, the electrons will lose energy and finally fall into the nucleus. Because whenever there is a movement, some energy is required. So electrons will not be moving all the time here. They will move and will lose energy and fall into the nucleus. Okay, this was the drawback. And this drawback was modified by Bohr model of atom. Bohr, B-O-H-R, Bohr. What he said that he modified Rutherford models of atom. He said that only certain special orbits known as discrete orbits of electrons are allowed inside the atom. Discrete orbit. Okay, not all the orbits in one path are accommodated. They do have different orbit, it is here now. And secondly, while revolving in discrete orbit, the electrons do not radiate energy, and that is why the electrons will not lose energy and it will keep revolving around it all the time without losing energy. So this was the Bohr model and it was accepted by all. Thank you.